So good morning, all of you MSc Physics student. We have to see here our second chapter is solar radiation and its measurement. The summary of the last lecture, we have to see here the characteristics of the sun and the nature of the sun, which described by that whatever radius, whatever mass, and what is the relationship between sun and earth. And after that, we have to see here solar constant and what is the value this and how it is calculated. In this lecture, we want to see the points which is considered as the electromagnetic energy spectrum, because you have to know that light which is considered as the electromagnetic rays, or that is the EM waves, and that is the energy which is considered as E is equal to that energy which is basically see as here, that E is equal to H into nu. This is the energy, this H is the Planck constant and nu is the frequency of light, and that is which is depends upon that nu is equal to C by lambda, and that nu which is considered as nu is equal to C by lambda, and this C which is considered as the velocity of light, velocity or speed of light, and this lambda which is considered as the wavelength of light, wavelength of light. So that consider this spectrum, that electromagnetic spectrum of the electromagnetic radiation, which is usually divided into the wavelength band, and this wavelength band which is considered by this lambda, and that unit which is considered measure here, that in terms of the microns. So that 1 micron, that is symbol for micron is mu, and that 1 micron is equal to 10 to the power minus 6 meter. So we have here in this spectral or spectra of this electromagnetic, there are the different types of the nature of the wave, that is considered as the cosmic rays, gamma rays, infrared rays, X-rays, ultraviolet rays, visible rays. That are the different spectral types of the this electromagnetic waves or rays, and whatever suitable that wavelength which is will be see here, and that wavelength band, so that the range which is between 0.1 micron to 100 microns, between this all of the suitable wavelength which is occur in this spectra. So we have to see here that approximate range of these spectral lines or spectral rays we have to consider here. So that we have considered here, so that the approximate range of the spectrum of whatever nature we have to wave is there, and that name. So first point which is considered as the approximate range, or we have to consider as the here name of the spectra, and here we have to consider the approximate range. Approximate range. So first point we have to consider here. So so first type which is considered as the cosmic rays. Okay, and that cosmic rays we have to that range which is considered as that lambda which is less than 10 to the power minus 8 micron. So we have to consider that range which is considered as lambda is less than 10 to the minus 8 micron. So this is the approximate range of the cosmic rays. Next which is considered as the gamma rays, and that gamma rays which is has the range which is considered as this 10 raised to minus 8 micron, which is less lambda less than 10 to the power minus 4. So that is range between the 10 to the power minus 8 to 10 to the power minus 4. So that next type which is considered as gamma rays. Gamma rays, and suitable range which is considered as 10 to the power minus 8 micron to 10 to the power minus 4 micron. So this is the range for the gamma rays. Next, which is considered as the X-rays, and that X-ray range which is considered that suitable, that 10 to the power minus 5 to 10 to the power minus 2. So that next rays we have considered here the X-rays, and that X-rays, that range which is considered as 10 to the power minus 5 micron, which is less than lambda less than 10 to the power minus 2 micron. So this is the range of the X-rays. Next rays which is considered as the ultraviolet rays, and that range which is considered as 2 into 10 to the power minus 2 lambda to 0.38 micron. So that next name which is considered as fourth type, so that is UV rays, or considered as the ultraviolet rays. Ultraviolet rays, and that range which is specifically considered as 2 into 10 to the power minus 2, which is less than lambda to less than 0.38 micron. Next, which is considered as the visible light of the rays, and that visible light of the rays which has considered visible light rays, and that range, specific range which is considered as is 0.38 micron, which is considered as less than lambda less than 0.78 microns. So this range which is considered as the visible light rays. Next, which is considered as the infrared rays, and that infrared rays which is considered as 0.78 micron to 10 to the power 2 micron. So that consider next type which is considered as infrared rays, and that range which is considered as 0.78 micron, which less than lambda less than 10 to the power 2 micron. Next type which is considered as the radio waves, and that range, specific range of these radio waves which is considered as radio waves, and that which is considered as 10 to the power 2 micron to 10 to the power 10 micron to 10 to the power 10 micron. So if we see, starting for here 10 to the power minus 8 microns to the 10 to the power 10 microns, so that electromagnetic spectrum we can sense those have wavelength which is approximately between 0.1 to 100 microns. So that electromagnetic spectrum we have to consider. Therefore electromagnetic spectrum approximate range between 0.1 micron to 100 microns. So that between these all types of this spectral electromagnetic spectra, that name which consider as the cosmic rays, gamma rays, X-rays, ultraviolet ray, visible rays, infrared rays, and radio wave. So that are approximate range we have to seen here. Now next point we have to see here that solar radiation at the earth's surface. Solar radiation at the earth's surface, and in this solar radiation at the earth's surface we have to see first type, which is considered as the terrestrial radiation. And in this terrestrial radiation we have to see different type, which is considered as beam radiation or direct radiation, diffuse radiation, total global radiation. What is mean by this, and how it is nature, and how it is transferred or absorbed in the atmosphere. So that part we have to see detail here. So we want to start the point, that is the solar radiation at the earth surface. Solar radiation at the earth surface. So we want to continue that our point, that solar radiation at the earth surface, and in this point we want to see that what is mean by the terrestrial radiation. So in last few lectures we have to see here that solar radiation which is in the outside the earth surface, and in this point we have to conclude the point or include points which is terrestrial radiation, that solar radiation at the earth surface. So that this point, which is the point of the view, that is the utilization of the solar energy, and that we are more interested see in the part which is energy received at the surface of the earth, and that energy which is received the surface of the earth or earth surface, then is the extra terrestrial energy, and that solar radiation which is received at the surface of earth, which is entirely different due to the various reasons. So that means what, that terrestrial radiation, that solar energy which is radiant or emit from the sun body, or which is received from the earth surface. So what type of direction, what type of the ways, that energy which is incident on the earth surface, so that different types we have to see here in this point. So that utilization of this energy and receiving for this energy on the earth surface, so we have to see the first basic type is here. So that is the beam and diffuse solar radiation, and in this beam and diffuse solar radiation, so that first point which is direct or beam radiation. So that point we have to see here, so beam and diffuse solar radiation. Beam and diffuse solar radiation, beam and diffuse solar radiation, and in this beam and diffuse solar radiation we have to see the first point is direct or beam radiation. Direct or beam radiation. Okay, so what is mean by the direct radiation or beam radiation? So that means by the portion of incident solar energy, that radiation which comes directly from the apparent solar space to the disk without reflection from the object, is called the direct or beam radiation. That means by, what is mean by this radiation? So that mean by, so whatever radiant energy or radiation which is emit from the sun, so that are directly incident on the earth surface, directly incident on the earth surface. That is mean by no reflection is there, no diffraction is there, no absorption is there. So directly this radiation, because of the high wavelength, high frequency, this is incident on the earth surface. So that means that the portion of the incident solar radiation, so direct or beam radiation which is considered as the portion of the incident solar radiation which comes directly from the which comes directly, so that the portion of the incident solar radiation which comes directly from the apparent solar from the apparent solar radiation from the apparent solar radiation which solar disk without reflection, apparent solar disk that without reflection from other object is called beam radiation or considered as the direct radiation. So that consider as this type of the solar radiation which is that direct or beam radiation, that portion of the incident solar radiation which comes directly from the apparent or solar disk without reflection from the other object is called beam radiation or direct radiation. So that means what? So for example this is the sun body, okay, which emits the solar energy or solar radiation, or okay, sun body, or for example this is considered as the earth surface, okay, this is considered as the earth surface. So whatever solar radiation which is directly incident on the earth surface, so that is considered as the direct radiation which is directly incident on the earth surface. So this radiation which is considered as direct radiation, and that main property which is considered as this radiation are received from the sun without change in direction. So this radiation is received on the earth surface. That is continue here point. So without changing direction of radiation. So that types of the beam radiation or direct radiation, so that radiation which incident on the earth surface, that without changing any direction. So that means what? Without changing any direction, that means by some radiation which is incident from this direction, some incident from this direction, okay, or absorbed by other body, or which is from this radiation, and afterly that for example this is known as the diffuse radiation, and this radiation by traveling by the other direction or traveling here there, and after we have to come in the earth surface or incident on the earth surface. So that type of radiation which is considered as the diffuse radiation. Diffuse radiation. And we have to concluding this direct radiation and this diffuse radiation, that all types of the radiation which is incident on this earth surface which is considered as the total global radiation. So this is the first type of the radiation, that is the direct or beam radiation, that the total that radiation which is incident on the earth surface which is directly without change in direction. So that is known as the direct or beam radiation. So now